last video we talked about how El Nino, La Nina, and more normal or Walker circulation occurs. And there was a table I showed you in the book that it would probably be in your very best interest to take a look at. This is sort of a visual depiction of that table, at least for the El Nino portion, as opposed to La Nina and normal circulation. And these little bubbles are a key and whatnot. One of the things you should take into note is that the most widespread consequence of El Nino is drought throughout large portions of the world. You would expect there to be drought in Southeast Asia, and there is. We'll talk about the Lewin Current, but there's also drought in Australia. Places where there's drought, there's frequently forest fires. So there's also forest fires in Southeast Asia. But there's also drought in Africa and the western part of South America when we have a severe El Nino event. Also, other places that don't typically get lots of precipitation frequently do. In the United States, we have some areas that get floods. Some places in South America get floods, especially along Peru, which can lead to lots of erosion and so on and so forth. So there are lots of these effects of El Nino that kind of stretch all the way across the world rather than just around the Pacific. So one of the questions we need to talk about is how often do ENSO events occur. For El Nino, it typically occurs somewhere between 2 to 12 years with sort of irregular patterns. The image below, red is warm phase, El Ninos, blue is cool phase, La Ninas, and the Pacific has alternated back and forth between these since 1950. There's been very few and far between periods of just straight Walker circulation, and that's been of interest to climatologists for kind of a long time. The events themselves, like a typical El Nino, last anywhere from a year to a year and a half. And then the La Ninas come after that. In the last 20 years, La Nina has been less common than El Nino. But if you look at this graph, you can actually see that from 50 to about 1980, La Nina was more common and longer lived. So that can shift. And the reason why the current thinking is that there's this thing called the Pacific Decadal Oscillation. And El Nino is due almost completely just to the shifting back and forth just along the equatorial Pacific. Pacific Decadal Oscillation is a much bigger climate phenomenon. It has to do with a lot of things like solar forcing, and it's interacting with all these other oscillation things, including the one that's being talked about a lot, the polar vortex, and the Atlantic Oscillation. And these come on 20 to 30-year patterns. So whether we favor El Nino or La Nina will be based on where in the Pacific Decadal, the PDO, we are. So I'm going to talk about two famous El Nino events. 82 to 83 was actually the strongest El Nino event on record. They make these climate models where they take into account temperature of the surface of the ocean and the actual pressure in the atmosphere, and they can assign a number to the strength of how shifted the circulation is. The increase in erosion along Peru was massive. There was landslides throughout Peru and also coastal erosion. There was I'm going to try that again. In the southwest of the United States, the rainfall was 3 times what it normally was. This is areas that would be very prone to flash flooding. In Peru itself, they saw 10 feet of rain in an 18-month period, which is insane. Not only did they see shifts in fisheries, but also corals, which can be killed with very warm water. Lots of them died throughout the world. And there were hurricanes in places that they just typically aren't found, such as French Polynesia and Indonesia. They get typhoons, which tend to be a little weaker, but they had true hurricanes. And there was droughts worldwide, Australia, Indonesia, China, Africa, and there were 2,000 plus human deaths related to these droughts. So that El Nino is one of the worst ones in human history. I don't really remember that one. I know I seem really old, but I don't remember that one. I do remember the first time El Nino really got a lot of chatter was in 1997 and 98. And you can see in this picture that just how shifted over the Pacific warm pool went. Right here. Let me do it in a better color. How about that? The Pacific warm pool shifted completely over. Normally it would be here. And it shifted all the way over to the Pacific. And that part of the Pacific was 7 degrees warmer than normal, which is, when you know what you know about the high heat capacity of water, is massive. This led to a record number of tornadoes in the United States and record amount of rainfall in California, which led to a lot of landslides. There was a lot of death associated with this El Nino, considering it wasn't quite as strong as the other one. But this one was a very famous El Nino event as well. So, in order to, after that big El Nino in 82 and 83, the world scientific community decided that somebody needed to be better at predicting these events. And so a joint venture began. It was called TOGA, or the Tropical Ocean Global Atmosphere. And it was used, it used a lot of different methods of gathering information. It was one of the first truly joint program. It had RVs, buoys, satellites, etc., and people from many different countries worked together to make these computer models. This was one of the first computer models that became very accurate. It's able to predict an ENSO event up to a year in advance, and it's predicted all of them. So the TOGA program was wildly successful. It did have limitations. There was a limit to the amount of money people were willing to put into it. People started pulling their RVs out. RVs are very, by RVs I mean research vessels, are very expensive to run. So one of the things that was suggested was there'd be 70, an array of buoys that gave real-time data. And this was the TAO program, Tropical Atmosphere and Ocean Program. And it was added to TOGA, I believe in the mid-90s. And these buoys are still online now. You can click on this link. I will put it in the website. But basically, you can go on and see TAO data right now. And this helps us to even better understand more of these atmospheric phenomenon in the hopes of, maybe better preparing for them, or helping people not, die from them. So enough ENSO. This is a picture of the Indian Ocean. Indian Ocean circulation is sort of unique. So we have to define a couple words. Monsoon are seasonal winds. A lot of people think that there are rains frequently associated with the monsoon, but the monsoon itself is just the wind. And during the winter in the Indian Ocean, even though it's called a monsoon, it's still a trade wind. And they blow from the northeast like we would expect like we would expect trade winds to do. And they set up a current, the Somali current specifically, that goes in the directions we would expect. In the summer, there are issues, and part of this is because this is purely a southern hemisphere ocean, or the vast majority of it's only in the southern hemisphere. And those monsoon winds actually shift direction, and they blow out of the southwest instead. And this is one of the few currents in the world, the Somali current. It completely reverses direction. So the Somali current does not always blow in the same direction, which is kind of interesting. This in turn has a huge effect on the Leeuwin current, which is in southern Australia. The Leeuwin current is responsible for providing moisture to the winds that blow across Australia. And during El Nino events, it typically blows winds that carry up to 50 inches of rain across Australia. But during the El Nino, there's major, major droughts in these regions. So even though El Nino is primarily a Pacific Ocean phenomenon, it has a effect on the Indian Ocean circulation patterns as well. All right, we're going to stop there for this video, and that'll actually be the end for the second quiz. So we'll do deep currents as like the last little bit of the chapter.